Hello, my name is Amal Kishor. I am from Cohort MSE2508A at AlmaBetter. This is my Module-2 End Capstone Project for course Design and Analysis of Algorithm. In this capstone project, I have solved 25 JavaScript-based DSA problems, which were from 5 categories: code bug fixing, improvised perspective, logic building, traditional versus optimized approaches, and best case and worst case analysis. In this video, I will explain 5 selected problems, specifically question number 1, 7, 13, 16, and 25, and I will discuss my approach and the challenge I faced and the strategy I used to solve them. Now I am going to explain question number 1. This problem is from code bug fixing. Goal here is to check if number is power of 2 or not. This problem here have a logical bug. Its usage or instead of and. So it will return true even if both condition not satisfied. Here just even if it's satisfied, the number is greater than 0, it will return true, which is not right for this function. So if we have replaced here or with and, so this both condition must be satisfied. This function here uses bitwise operation. Here first it check if number is greater than 0, then it's apply bitwise operation. Key idea here is that a number which is power of 2 have only one set bit of binary. So if we subtract 1 from power of 2 here, it will return 0. So this is the key idea in bitwise operation we check. So now I am going to explain question number 7. So this problem is from the improvised approach. Goal here is to determine whether a given number is palindrome or not. A palindrome is a number that reads same from forward and backward. So this function uses most common approach, which is to reverse the number here and then check from original, compare from the original number. So I have used in my approach here 2-pointer approach. I have converted my string into my number into a string. Then I have used 2 pointer, one left pointer and right pointer, and I move the pointer from both sides. In the middle here it goes from left and right from backward, it's come back from right here until it's meet in middle. If both number anywhere not equal, it's return false here and number is not palindrome. And if this condition passes, if anywhere my left side of pointer and right side of pointer finds equal number, then it's move and meet in the middle and it's return true. So my number is palindrome. Here you check left pointer and right pointer, so it's all right pointer goes this left and my left pointer goes right. If she find same here number is a 1 1 2 2 and then meet in middle 3, so this number is palindrome. If anywhere it's let's say here were 4, so anywhere it's not meet 2 4, then this number would have been not palindrome. So this is the problem. Now I'm going to solve question number 13. So this problem is from the logic building. In this problem we are given an array of numbers with positive, negative and zeros, and we have to count positive number and negative number and return which is maximum from both positive and negative. To solve them, I have used here two counter, one for positive number and one for negative number, and then I goes to every traverse in the array, and here I count positive and here I count negative, and I ignore 0 here, else continue, and return maximum, which is if positive is max I return positive, if negative is max I return negative. So here I use math.max. so just if here take example, here I have an array, here array is given, so it's count negative, so let's say it's count 1 2 3 negative and 3 positive. So math.max is equal, both are equal, so output will be return 3, and here 0, and here also positive, negative is 3 and positive are 3. Just here return, it's ignore 0 and also return output 3. So this is the problem. Now I am going to explain question number 16. So in this problem they are given two approach, traditional approach and optimized approach. In this we have to analyze the both approach. So in this problem we have to find missing number in given array from range of value 0 to n. So in this traditional approach, here is this solution uses head set, and here it's push the all head set in new array, then it's check the each integer from 1 to n. If integer is not in head set, then it's return I, and if it present, we are return 0. So here optimized approach uses cyclical sort. So first it's rearrange the number. Here it traverses from last to end and rearrange the number from 1 to n. Here it's integer 0, ignore the here 0 here, then rearrange all the integer from first to last on the index 0 to n. Then here if any integer here skips, then it returns I plus 1. So if any integer here is not I plus 1, then return that a skipping number, and it's if passes all, then return n plus 1. So here again I explained your goal to identify single missing number from array containing n distinct value from range 0 to n. Then I provided comparison here. So in the traditional approach uses extra set to store element, then check which number from range 0 to n is missing. So here time complexity O1 ON and space complexity ON due to head set. So here a space complexity increases because here in has set, it's create another set so to a store, so a space complexity increases. While in optimized approach, here in cyclical positioning technique, what does the time complexity is same GON, but a space complexity reduces because no extra data structure used here, so it's eliminate the additional memory. So optimized approach eliminate additional memory usage because it's use less space. So I am going to explain question number 25. In this problem we have to find length of last word of the sentence. So in this case we have to write two cases, worst case and best case. So in this case I have used the classic method where I have splitted the word here, then I filtered the word if it have any interesting, then I here taken the last word and return the length of the last word. So it's very simple. Then I have here in best case what I have done, I have taken the variable length, so here I have counted the length and I have traversed the sentence from the last. Here first I have traversed the sentence for last. If it has any space here, that I have skipped here. So then again I have counted the last word until a space is found. So I have counted the backward from last length. Here I have taken the last, I here is dot length -1, so I have taken the last character and then I have traversed the backward and then until a space is found. When a space is found in between of the sentence, so I have returned the length. So I'm going to explain how it works. Let's say this is fly me to the moon is a sentence. So what I have done is in your best method is I first here I have counted until the a space here if a space, then I have skip the space. So here I have the space, skip the spaces until land on in here. Then in second loop here, count loop, I have what I have done, I have traversed the moon, so until this space is not found and counted. So first it goes to N O O N, so I have counted N O M, then I stopped at the space, then output is 3, output is 4. This is the 25. So I have explained all my 5 problems. So through these 5 problems I have demonstrated my understanding of DSA, logical reasoning and time and space complexity. So I have completed my capstone project of DSA. Thank you for watching.